Okay, let's now fill out our geometry cheat sheet for triangles. So the first rule on our list says the relationship between the three sides of a triangle. So this is just the rule that says the sum of the lengths of any two sides of your triangle must be greater. They cannot be equal. They must be greater than the length of the third side. So if I have a triangle that looks like this, and it looks like a legitimate triangle, but then I tell you that the lengths for its sides are 3, 4, and 7, even though this might look legitimate, this is an imposter triangle. It is impossible because 3 plus 4 is equal to 7, and the sum of these two sides must be greater than 7. So, whereas if I had a triangle like this that looked similar, but now it was labeled as 3, 4, and 6, now this is legitimate. And to determine that, you really have to check it 3 ways, right? Because you need to check that 3 plus 4 is greater than 6, 3 plus 6 is greater than 4, and then also 4 plus 6 is greater than 3. So because all of those things are true, this guy checks out. One way they like to test this rule, because it's a pretty simple rule, and I think nothing gives the GMAT test writers more pleasure than taking an easy concept and finding a way to test it in a complicated way. So a lot of times they'll say something like, what are the possible lengths for side X? Or what is the range for side X? So to do this, if you want to find all the possible values that X could be, well, X has to be less than the sum of the other two sides, and it also, though, must be greater than the difference of these two sides. So in this case, X must be between 10 and 4. Cannot be equal to 4 or 10. It must be between those two values. So the reason for this is because, what do you know? So from this triangle, if you know your three sides are 3, 7, and X, well, then you know 3 plus 7 must be greater than X, and you know 3 plus X must be greater than 7, and you also know that 7 plus X is greater than 3. Now, this last guy here is not really relevant, right? Because 7 plus anything is going to be greater than 3, so this doesn't really even tell you anything. And so from these two, if you want to just then get them in terms of X, this is telling you X is less than 10. And then if I just rearrange this guy here is telling me X must be greater than 4. So between these two guys, X must be between 4 and 10. Another way of putting that, X must be less than the sum of your other two sides, but it also must be greater than the difference of those two sides. The relationship between the three side lengths of a triangle and its angles. So this is our rule that says the relative lengths of the three sides of a triangle will correspond to the relative size of the angles opposite those sides. So if I have a triangle and I tell you that this angle here is 40 degrees, this angle here is 80 degrees, And that means this angle here must be 60 degrees because I got a sum to 180. So if I was to then say the lengths of the sides for this triangle are 5, 10, and 7, and then I asked you to label where these lengths should go, well, you would know that the smallest length, so the 5, has to be opposite the smallest angle. So this guy here is the 5. Your middle length, so the 7, has to be opposite the middle angle, so that would be opposite the 60. And then your longest side has to be opposite your biggest angle, so your 10 is opposite the 80. Relationship between the three sides of a right triangle. So this is just Pythagorean theorem. Once you know you have a right triangle, and this side has a length of A, this side has a length of B, then you know that A squared plus B squared is equal to C squared. So C is the length here, the length of your hypothesis, or your hypotenuse, I should say. So your Pythagorean theorem, when you find C squared, remember, that is not the length of your hypotenuse. The length of your hypotenuse is still just C, and so C is really equal to, because that's usually what you're trying to find, that's going to be the square root of A squared plus B squared. But usually this is the formula that people remember. Just remember, to get C, or to get the length of your hypotenuse, you just got to take the square root of that guy here. Common Pythagorean triplets. So I don't know if we talk about these. These are things that might just save you a little bit of time. You should never really have to be using these, because all of these can be derived quite simply using Pythagorean theorem. They're just ones that show up commonly enough, it might be worth memorizing. So the thing to keep in mind is that you can only use these when you have a right triangle, because that is the only time you can use Pythagorean theorem. So first you need to have a right triangle, and then the most common Pythagorean triplet is a 3, 4, 5 triangle. So, you know, this side here is a length of 3, this side here is a length of 4, this one here has got to have a length of 5, and this also works for triangles that are in the same proportion. So for example, if I have a right triangle and I know this side is a length of 6 and this is a length of 8, this must be a length of 10, because this is really just a 3, 4, 5 triangle, just I multiplied all of my values by 2. So the mistake to avoid is assuming you have a 3, 4, 5 triangle when you don't know that you have a right triangle. So if they give you a triangle like this, they say this is 3, and they say this is 4, not say this guy here is 5. That would only be true if this angle here were a 90-degree angle, which it does not look like it is. The side ratios of a 45, 45, 90 triangle. So this is our first special right triangle. So first it's got to be a right triangle. And then we said once you know it's a right triangle, you just need to know 2 things. So you need either 2 of the angles or you need 2 of the sides. And so if I know this side here is equal to 3 and this side here is equal to 3, well, now I have a right triangle, I know 2 of my sides, so I know I have a 45, 45, 90 right triangle. So if this is 3, 3, this must be 3 rad 2, because the side ratio. So once you know you have a 45, 45, 90 triangle, that means the ratio of your sides is going to be x to x to x rad 2. And we also said common code for a 45, 45, 90 triangle is sometimes they'll say if you have a isosceles. right triangle. Same thing. The side ratios of a 30, 60, 90 triangle. So this is our second special right triangle. So if I know I have a right triangle, and I say this angle here is 30, so now I have two things I need. I have a right triangle, and I have two of my angles. Therefore, this has got to be 60. Therefore, I know I have a 30, 60, 90 right triangle, and I know the proportions for all my sides. So say I was to say, this guy here, they use the same numbers before, 3. So that means here, so if the side opposite my 30 is 3, the side opposite my 60 is 3, we're at 3. The side opposite my 90-degree angle, or my hypotenuse, is going to be 2 times 3, or 6. So this means the ratio of your sides for a 30, 60, 90 triangle is x rad 3 to x. So, or x. So your side lengths are always referred to the side opposite the angle that it matches up with. So the side opposite the 30 is our x. Side opposite the 60 is our x rad 3. And the side opposite 90 is our hypotenuse, which is 2x. The area of any triangle, so this everybody should know, that is just 1/2 base times height. Only mistake not to make is, so this is easy when you have a right triangle. I know this is a right triangle. You can say this is the base, this is the height. But that is not always the case. Remember, the height has to be a line that is perpendicular to your base and also connects to the opposite vertex. And so a triangle like this, if I'm saying this is the base, I cannot say this guy here is the height, because it's not necessarily perpendicular to here. So I would have to find the corresponding height to this base. And so it looks like that line would actually sort of be here. You'd have to extend this. And you'd have to find the length of this guy to get your height. And then you can do 1/2 base times height. Properties of isosceles and equilateral triangles. So the first property is an equilateral triangle is an isosceles triangle, but not all isosceles triangles are necessarily equilateral triangles. So with an isosceles triangle, you got two sides that are equal to each other, and therefore the angles opposite those sides must be also equal to each other. And also with isosceles triangles, we have isosceles right triangles, which we said before is just a 45, 45, 90 triangle. Now with equilateral triangles, so we know all of our sides have the same length. Here we said these two sides are the same, so x and x. Well, here we know all three sides are the same length. Therefore, the angles opposite those sides must be the same. And since the sum of the angles of a triangle is 180, we know each of those angles has to be 60. We don't necessarily know the value of our angles with an isosceles triangle. So if I were to tell you that x here is equal to 5, that doesn't necessarily mean that there is some, that, these guys here have to be 40 or something. I just know whatever the value for these angles here is, they're equal to each other. So if this y here is equal to 40, this guy here also has to be equal to 40. With an equilateral triangle, you not only know your angles are equal, you know what that value is. Something else about equilateral triangles that, whoops, I don't know if we mentioned. you can find the area of an equilateral triangle with a special formula. And so if I was to say, if I was to label the side of an equilateral triangle as just S, the area for an equilateral triangle is equal to S squared rad 3 over 4. So you can use 1/2 base times height for an equilateral triangle, because you can always use that. So the height is going to be this guy here. Or you can use this formula here. So why is this useful? Because this formula, I would say, actually looks more difficult than 1/2 base times height. Well, you would use it in something like a data sufficiency question, because think about what this is telling you. This is telling you that if normally you need to know 2 things to find the area of a triangle, you need to know the base and the height. For an equilateral triangle, you only need to know 1 thing. If you know the value for any side of an equilateral triangle, you can find its area. And really all this formula is it is 1/2 base times height. But it would be if you just, in this case, so if we called all of our sides S, then we just got our height here in terms of S, and then did 1/2 base times height. It would give you this formula here. Rules for determining similar triangles. So similar triangles, they are going to have all corresponding angles. Are equivalent. I think sometimes people just think, oh, similar triangles, that means all the angles are equivalent. But that sort of makes it sound like you have that they have to be equilateral triangles, which isn't necessarily true. So I always say all corresponding angles are equivalent. All sides are in the same proportion. So this is true once you have your similar triangles lined up so that their angles correspond properly. So if I know that the values for the angles of this triangle here are X, Y, and Z, and then I say this triangle here is similar to it, I want to make sure I orient this triangle so that my X angle is here, my Y is here, and my Z is here. And then once I know that all my sides are in the same proportion. If I said this side here is a length of A, and this side here is a length of 3A, well then if I said this side here is length B, this guy here must be 3B. And the other rule we said, the slightly more obscure rule, is if you have a height that is dropped from the right angle vertex of a right triangle, and it divides and it splits that triangle into 3 similar triangles. The diagram for that looks something like this. So if I know I have a right triangle here, and then I drop a height from the right angle vertex of that right triangle. So a height would be something that is perpendicular to the opposite side. So this angle here, this is how I know I have a right triangle. And to know I have a height, it has to be a line that forms a right triangle with this guy here. Then you can say this is the base. This here is the height. So in this case, then it would split this triangle here into 3 similar triangles. And then remember, you have to make sure you orient. I like separating them out, but you have to orient those triangles so that their angles line up. So those 3 triangles are this one here. So if we say this is triangle A, and we got triangle B, then the third triangle is the big triangle. Because remember, that is also part of your entire set of triangles. A rule for a right triangle inscribed in a circle. So this said, so first, what does inscribed mean? So inscribed means a triangle that where all 3 of its edges, all 3 of its vertices touch the edge of the circle. So if you have a triangle inscribed in a circle, and it is a right triangle, then its hypotenuse is the diameter of the circle, and vice versa. So if you have a triangle that is inscribed in a circle, and its hypotenuse is the diameter of that circle, then it must be a right triangle. So I have something like this, inscribed triangle. Might look like this. So it's usually going to look like you have a right triangle, but unless you have more information, you cannot always assume that. So only if they then tell you that BC, or if you can figure out that BC is the diameter of this circle, then you know you have a right triangle. Then we left the easiest one for last. Sum of the angles of a triangle. I think we've said it like 5 times already. 180 degrees. That is it for triangles.